Okay, here's another problem that asks us about for the particular number of people that are less than or greater than a certain value. So this is the problem that was about a Lyft driver. So I'll just go back to it previously. It says during a certain time of day, the wait time for getting picked up by a Lyft driver is approximately normally distributed with mean 6 minutes and standard deviation 2 minutes. If you decided to get a Lyft ride, what are the chances or percentile of certain things happening? Then they said, okay, suppose that 500 people are randomly asked to report their wait time for the Lyft ride. Using the information given in the previous problem, estimate the number of people, not percent, but actual number of people with this wait time. That means we're going to have to find the percent, very similar to the way that we did in this first part of the problem. But then after we do that, we're going to take that percent and turn it to a decimal and times it by our number in our sample, which is 500. So this first part says, part A, estimate the number of people with wait time 2 minutes or less. So really quickly, the last question in the previous example said the wait time will be 2 minutes or more. So the percentage was 97.5. So if we just take that value and do 100 minus that, then we're going to find how much is less than 2. And the reason because they're asking us for this, how many people are 2 or less, which is the area of this region. And we just found the area of the opposite side of, so if we just take 100% is all the area under the curve, or all the data under the curve, and then we take away what's above 2, then we'll find out what's below 2. Okay, so we just do, for this first one, we just do 100% and take the 97.5 from the previous problem, and we get 2.5%. So 2.5% of the people. So I'm just going to erase these. I don't think I need all those. And I'm just going to write in here that we need to do 2.5% of 500. Well, that I move the decimal twice to the left, and for every empty trough, I would do a 0. So it's 0.025 times by 500, and I get 12.5, which I would round up to approximately 13 people. So erase this, like, don't worry about that. Okay, approximately 13 people. Okay, for the next problem, it says 4 minutes or less. So what we're trying to figure out, first we need the percent that are 4 people or less. So that's this area. So we do know that this area is 68% of the data is between 1 standard deviation below and 1 standard deviation above. And and we also know that 50% of the data is below this. So 68 divided by 2 is 34. So we know that this region is 34 because this region was 68 and divided by 2 is 34. So that area is 34. So I can do 0.5 or 50% minus 34, and that will give us 16. So there's 16 this pink area is 16%. So now we need to find out what is 16% of 500. and I get 80. So about 80 people. All right, the next one says 6 minutes or less. So, oh, this one's not too bad because 6 is right in the middle. And so we know that half the data is underneath, and 6 is the mean. So half the data is underneath that. So we just need to find out what half of 500 is, and that's 250. Oh, 500. I'm writing down the answer already. It's about 250 people. Okay, then 8 minutes or less. Well, that is this region. And we just said that this region is 34 between the mean and 1 standard deviation above the mean. So this is 34. And then we just said that this area from the mean all the way to the left of the mean is 50. So we need to do 50 plus 34, which is 84. So 84% of the data is 8 minutes or less. So now we just have to find out what is 84% of 500. Move the decimal twice to the left to get 0.0844 times 500. And that is 420. All right, 10 minutes or less. I'm going to use one of my drawings over here. So this is 10. Oh no. Oops. $10 minutes or less. That's this area that I'm trying to find. 10 is 2 standard deviations below the mean. So I need to find out how much is outside, because this is the area outside of 2 standard deviations, or half of the area outside of 2 standard deviations. So I'm going to do 100 minus 95. That's 5%. 5 divided by 2 is 2.5. So this area is 2.5. So we can do 100 minus 2.5, or you could have done there, because on this side is also 2.5. So you could do 95% plus 2.5, or you could do 100% minus 2.5. Either way, I did 95 plus 2.5, and I got 97.5. And then now I have to do 0.975 times by 500 to get the percentage. And that was 487.25, which is approximately true. Like I said, I don't like to have which is approximately 487 people. I just round naturally. Oh, wait. Okay. Actually, this was not 2.5, it was just 0.5. So it'd be 488. There we go. Okay, and then the last one. Here's the picture over here. So it's 12 and under. 12 is 3 standard deviations above the mean. So this is half of the area outside of 3 standard deviations. So this region, oops, I didn't put 3 standard deviations, it was 0, it was 3 standard deviations. Between here and here is 99.7% of the data. So if I do 100 minus 99.7, I get 0.03. And if I split that in two, because there's two equal regions outside of the 99.7, then it's 0.015. So what I can do is I know this side is 0.015%, and this is 99.7, so we can add it. So 99.7 plus 0.15, and I get 99.85. So we need to find 99.85% of the sample, which is 500. So I can move the decimal twice to the left. I get 0.09985 times 500, and that gives me 499.25, which I'm going to round to 499. I wouldn't really want to round up there, because like if I say 500, that means all the people are going to be less than 12, but we know there's a little bit, because of this region, there is a few people that are more than 12. So I want to at least show that one person is less than 12, but I'm just going to round naturally. So I guess if it was 499.7, I guess I would have rounded up to 500 and just said, well, approximately no one is going to have, and that makes sense. And if it's so rare, we wouldn't expect that in that sample size to have anyone with that characteristic. So anyways, that is this example. I hope that it was understandable. Have a great day. Bye.